In this lesson, we will discuss a method to integrate certain functions by an appropriate trigonometric functions. Now, some of these integrals can be actually made much simpler using this trigonometric substitution. That means you must be familiar with some of the trigonometric identities that we are going to use here. And one such trigonometric identity is 1 minus sine squared theta equal to cos squared theta, or cos squared theta equal to 1 minus sine squared theta. The second one is secant squared theta minus 1 equal to tan squared theta. And the third one is 1 plus tan squared theta equal to secant squared theta. You must be able to use these three identities in doing our substitution. So you must be very thorough with these. And trigonometric substitution is useful for integrating expressions of some basic forms like square root a squared minus u squared. Now, you see, when you have a square root quantity, our aim is to get that square root out of the way so that we can simplify it and make it in a form we can integrate it. For example, if square root of a squared minus u squared. Now, which of these three forms will actually simplify this? Now, let us say u equal to a sine theta. Now, I'm going to write that down for you. Let's make a substitution like u equal to a sine theta. Now, why did I decide to do that? You have u equal to a sine theta. Now, what is du equal to? Du equal to a cos theta. Is that right? So, when you replace your u by a sine theta, what will our u squared be? The quantity now becomes a squared minus u squared is a squared sine squared theta. Now, at the moment, we are not going to look at du. We will simply simplify the square root quantity. Now, this can be written as square root of a squared can be factored out, a squared times 1 minus sine squared theta. Now, look at the way a simple substitution like u equal to a sine theta brought this quantity 1 minus sine squared theta. So this 1 minus sine squared theta can now be replaced by cos squared theta, and if you notice, a squared times cos squared theta, that will be square root a squared times cos squared theta, and that will be a cos theta. It became a very simple form which can be integrated. So, whenever you have this form a squared minus u squared, what is the substitution that you will make? You will make the substitution u equal to a sine theta. Alright, let's look at another basic form. Alright, now the next basic form is square root of u squared minus a squared. Now tell me, in this case, in order to take that square root off, what kind of substitution will you do? What will you call u equal to in these three forms? Well, it must be u equal to secant theta. If you call u equal to a secant theta, that a has to be taken into consideration. If u equal to a secant theta, then you have u squared equal to a squared secant squared theta. Is that right? And you can factor out that a, and you can come up with something like this. And the third one is square root of a squared plus u squared. And you can see obviously that will be of the form u equal to a tan theta. Is that right? Alright, now we will see how these forms are replaced by an appropriate trigonometric function or identity in order to make these integrals simpler. Now, in the expression a squared minus u squared, substitute u equal to a sine theta. I just did that for you. That gives me square root a squared minus u squared equal to square root a squared minus u squared is a squared sine squared theta, and factor out the a squared and replace 1 minus sine squared theta by cos squared theta. That give you a cos theta. That became very simple. And what did we say we substitute here? Square root u squared minus a squared. We substitute u equal to a secant theta. What will that become? That will be square root of u squared become a squared secant squared theta. And factor out the a squared. That gives you a squared times secant squared theta minus 1. What is secant squared theta minus 1? Equal to tan squared theta. So that will be square root a squared tan squared theta becomes a tan theta. And finally, in the expression square root a squared plus u squared, we substitute u equal to a tan theta. When u equal to a tan theta, u squared will be a squared tan squared theta. So that becomes square root of a squared plus a squared tan squared theta, and a squared is factored out, and then replace 1 plus tan squared theta equal to secant squared theta. So that will be square root a squared secant squared theta, and that is a secant theta. So by doing this appropriate trigonometric substitution, we made this sort of complicated quantity into a manageable terms that can be integrated. Alright, now let's summarize this. Form of the expression and what is the substitution that you will make. And you need to learn this and have to be very careful in your substitution. The form of the expression square root a squared minus u squared. What is the substitution we make? U equal to a sine theta. Alright, the second expression square root u squared minus a squared. What is the substitution that you will make? U equal to a secant theta. And finally, square root a squared plus u squared. The substitution is u equal to a tan theta. So keep this table with you and refer to this whenever you use this method of trigonometric substitution. Alright, let's practice this with an example. Evaluate the indefinite integral. Integral 1 over x squared square root 25 minus x squared dx. Alright, now the basic quantity you look here is this square root 25 minus x squared. What form is it? It is of the form square root a squared minus u squared. So what is your a? What is your u? Those are the things you must think about. So we have the expression square root 25 minus x squared on the denominator. And this is of the form, undoubtedly, of the form a squared minus u squared on the square root. With your a squared equal to 25, therefore a equal to 5, u squared equal to x squared, therefore u equal to x. Now, therefore, what is our substitution? Our substitution must be u equal to a sine theta, but in our case u equal to x. So we say x equal to 5 sine theta, u equal to a sine theta. In this case u equal to x and a equal to 5. So we substitute x equal to 5 sine theta. Now remember, when you make a substitution of one quantity, every other x must follow this substitution. That means we need to replace the dx. We also need to replace that x squared. So what is dx equal to? If x equal to 5 sine theta, dx equal to 5 cos theta d theta, and x squared is 25 sine squared theta. That means when you replace this 25 minus x squared as, well, we will replace x as 5 sine theta. When this x is replaced as 5 sine theta, this dx need to be replaced by 5 cos theta d theta, and this x squared need to be replaced by 25 sine squared theta. Let's do that. So this integral now become integral x squared is replaced by 25 sine squared theta. The x squared inside the square root is replaced by 25 sine squared theta, and dx is replaced by 5 cos theta d theta. We first start by simplifying inside the radical sign. We factor out a 25, so that will be, everything else remain the same. We deal with this. We factor out a 25. That will be square root 25 times 1 minus sine squared theta. Now look at the desired form that we created here. What is 1 minus sine squared theta? Is cos squared theta. So this 1 minus sine squared theta will be now replaced by cos squared theta, and the quantity inside the square root now is 25 cos squared theta. Okay, now 25 cos squared theta under square root now becomes square root 25 is 5, square root cos squared theta is cos theta. So we are going to remove that square root sign, and now we have integral, look at that, d theta is 5 cos, the dx has been replaced by 5 cos theta d theta. So that would be 5 cos theta d theta divided by 25 sine squared theta, and this quantity in the square root is now 5 cos theta. And if you notice, the 5 cos theta and the 5 cos theta will cancel. What do we have? We have integral 1 over 25, we take that 25 outside, 1 over 25, 1 over sine squared theta d theta. Alright, and what is 1 over sine squared theta? 1 over sine squared theta is cosecant squared theta. Now, can you integrate cosecant squared theta d theta? Yes. The derivative of cot theta with respect to theta is negative cosecant squared theta. Therefore, integral of cosecant squared theta d theta must be, yes, negative cot theta. So, that is 1 over 25, integral cosecant squared theta d theta is negative cot theta plus c. Those basic integration forms you must be very familiar with. Well, now we have been asked to integrate a function of x, and we have obtained the result as a function of theta. That is not acceptable. That means we need to now go back and replace theta in terms of x. How do we do that? We've got to go back to our substitution. Now we use the original substitution to write the answer in terms of x. Our answer needs to be in terms of x. So what is the original substitution? x equal to 5 sine theta. Now, can you visualize a triangle where theta is an acute angle and sine theta equal to x divided by 5? There you go. Sine theta equal to x divided by 5. So what we do is, we draw a right triangle with theta as an acute angle and decide on the sides of the triangle using this substitution. So this is our triangle and this is our angle theta, the acute angle. Sine theta is opposite side divided by hypotenuse. That means the opposite side is x. The opposite side of the angle theta is x. So this is x and the hypotenuse is 5. Alright, if the hypotenuse is 5, the opposite side is x, what is the adjacent side? The adjacent side will be square root of 25 minus x squared. Well, I'm sure you have no problem following that. In a right triangle, we have 5 squared plus x squared equal to, suppose I call the adjacent side as y. So I have 5 squared plus x squared equal to y squared if the adjacent side is y. No? Is this right? No. It will be x squared plus y squared equal to 5 squared. Pythagorean theorem. The square of the sum of the squares of the two legs. X squared plus y squared equal to 5 squared. Not this. Alright, just delete that. And that will give, if you solve this, you will get y equal to square root of 25 minus x squared. And that is what is expected in here. That means when the opposite side is x, the hypotenuse is 5, the adjacent side is 25 minus x squared. So we can now use this to obtain these quantities in terms of x. What is cot theta equal to? Cot theta is adjacent side over the opposite side. Is that right? Yes. So cot theta is adjacent side divided by the opposite side, and that will be square root 25 minus x squared divided by x. That means this cot theta will now be replaced by square root 25 minus x squared divided by x, and that gives us our original integral quantity is this, equal to negative. Negative comes from here. Negative cot theta is square root 25 minus x squared over x, and of course multiply by 1 over 25, and this is our final result. And look how simple that integration was made as a result of this beautiful substitution. Okay, let's do another one. Evaluate the indefinite integral x cubed over square root x squared minus 4 dx. Alright, I want you to look at the square root quantity. That is what is going to give you the clue. What form is this? I have given you 3 forms. Square root of a squared minus u squared, square root of u squared minus a squared, and square root of a squared plus u squared. Which form is this? Square root x squared minus 4 is of the form square root u squared minus a squared, where our u is x, our a is 2. Is that right? So this is of the form square root a squared minus square root u squared minus a squared, with a equal to 2 and u equal to x. So what is our substitution? Our substitution is x equal to a secant theta, u equal to a secant theta, our u equal to x and our a equal to 2, So we write x equal to 2 secant theta. If x equal to 2 secant theta, what is x squared? X squared is 4 secant squared theta. And x cubed is 8 secant cubed theta. And dx, what is dx equal to? Dx is 2 times the derivative of, or the differential of secant theta is secant theta tan theta d theta. So when you substitute x equal to 2 secant theta, our dx becomes 2 secant theta tan theta d theta, and x cubed becomes 8 secant cubed theta, the cube of this quantity. X squared is 4 secant squared theta. There you have. So all these quantities, now there's a small printing error here. X squared is 4 secant squared theta, not secant cube. X cubed is 8 secant cube theta. X squared is 4 secant squared theta. Alright, let's take all this into the integral. X cubed is replaced by 8 secant cube theta. X squared is replaced by 4 secant squared theta. And dx is replaced by 2 secant theta tan theta d theta. There you go. Now, where do we start the simplification? Inside the square root sign again. 4 is a common factor, we factor it out. So 4 comes out, and what is remaining is secant squared theta minus 1. And what is secant squared theta minus 1? Well, secant squared theta minus 1 is tan squared theta. So we replace secant squared theta minus 1 as tan squared theta. The quantity inside the square root now becomes square root 4 tan squared theta. Now, how does the top became 16 secant to the power of 4 theta tan theta? If you look at here, this is our x cube, this is our d theta. So you have 8 times 2 is 16. Secant cube theta times secant theta is secant to the power of 4 theta. And then a tan theta and a d theta. So this is our integral now in terms of theta. What is our next step? Well, square root of 4 tan squared theta is 2 tan theta. That is what we do in the next step. And we have a tan theta, and a tan theta goes. 2 goes in 16 8 times. So let's do that. Uh-oh. That 8 must stay up there, not down here. Is that right? Right. So that will be integral 8 secant to the power of 4 theta d theta. Well, now the question is, how do we integrate that? 8 can come out. So let's try that. That will be 8 secant squared theta. We have integral 8 secant to the power of 4 theta d theta. We take the 8 outside and split the secant to the power of 4 theta as secant squared theta times secant squared theta. Why did we do that? Well, remember, in order to integrate, say, secant something, you need to have a tan. See that the derivative of tan theta is secant squared theta. So, if we have a tangent followed by secant, the power of a tangent followed by secant can be integrated, because the derivative of tangent is secant squared theta. So you have secant squared theta times secant squared theta d theta. If you want to leave this part to take care of our du, then what must be our u? If this has to be du, then u has to be tan theta. Can you change this first secant squared theta in terms of tan theta? Yes, you can. Secant squared theta is 1 plus tan squared theta. You see how easily it gets transformed. Now you have, if you now replace tan theta by u, then secant squared theta d theta will be your du. Very simple. So tan theta equal to u, secant squared theta d theta equal to du. This now becomes h integral 1 plus u squared du, and this is now can be easily integrated. Alright, now that will be integral 1 du is u plus integral u squared du is u cubed over 3. So that will be 8 times u plus u cubed over 3 plus c. Well, we bring back our substitution. What is our u? U is tan theta. So the value of that integral is now 8 times tan theta plus tan cubed theta plus c. But again, this is not the result that we want. We want the result in terms of x. So we now go back to our original substitution. You remember our original substitution when we started? Yes. It is x equal to 2 secant theta. That was our original substitution. So we used the original substitution to write this result in terms of x. What do? Now, the original substitution is x equal to 2 secant theta. And now, in order to figure out what these quantities are, we need to draw a triangle using this. What kind of triangle? Well, we draw a triangle such that secant theta equal to x divided by 2. Alright, let's draw the triangle here. This is the angle theta. What is the meaning secant theta equal to x over 2? What ratio is secant theta? Remember, secant theta is the reciprocal of cos theta. Cos theta is adjacent over hypotenuse. Therefore, secant theta is hypotenuse over adjacent. So if secant theta is x over 2, it means the hypotenuse is x and the adjacent side is 2. So this gives the hypotenuse equal to x and the adjacent side equal to 2. In that case, what will be the opposite side? If the opposite side is y, just like earlier I told you, then y squared plus 2 squared equal to x squared. Let me write that down for you. So if the opposite side is y, then y squared plus 2 squared equal to x. Therefore, y will be square root of, will be x squared there, square root of x squared minus 4. Is that right? Yes. Because y squared plus 2 squared equal to x squared. Y squared is x squared minus 4, or y equal to square root of x squared minus 4. So the opposite side will be square root of x squared minus 4. There you go. So we label the opposite side. Once you have all the 3 sides, we can now pick these ratios. What is tan theta equal to? Tan theta is opposite side over the adjacent side. So you can replace now all of these using that ratio. And that will be tan theta is square root x squared minus 4 over 2. And tan cube theta will be raised the whole thing to the power 3. So we have, it will be tan theta, that is this, plus tan cube theta is you raise the quantity tan theta to the power 3. Alright, how do we simplify this? Let's simplify this. Now, one way to look at this is square root x squared minus 4 to the power of 3 divided by 2 cubed. and that 2 cubed is 8. 8 times 3 is 24. The denominator there will be 24. So we have, what I've done is I have factored out a square root of x squared minus 4 over 2. Now look at that. There is a square root x squared minus 4 over 2 here. And there is a square root x squared minus 4 over here. When you factor that out, there will be a 1 left here, and a square root x squared minus 2 to the power of 2 will be left there. There you go. This is just like a plus a cube over 3, and you factor out an a, you get 1 plus a squared over 3. That's what is in here. So once again, you factor out x squared minus 4 from both these, x squared minus 4 over 2, this quantity. When you factor it out, this is left with a 1, and this is raised to the power of 3. Only one of them is factored out, so you are left with square root x squared minus 4 over 2 raised to the power of 2 over 3. And when you simplify this, raise this to the power of 3 will give you x squared minus 4 over 4. And that 4 and 3 becomes 12. So you have this 2 goes with that 8, gives you 4 there. So this will be 4 times x squared minus 4. And inside the parenthesis now will be, this is 2 squared, that is 4. 4 times 3 is 12. And this is square will be x squared minus 4. And now simplify that again. Now take 12 as the common denominator and bring it out. When 12 is the common denominator, this 1 will multiply by 12. And the 12 comes out, this 4 goes with the 12 3 times. So this quantity now becomes x squared minus 4 over 3. And inside the parenthesis now, the 12 has actually come out. So it will be 12 plus x squared minus 4. And one more step, and that will be square root x squared minus 4 over 3 times x squared plus 8. 12 minus 4 is 8. And that is the result of integrating this quantity. Alright, practice this one more time at your own time. Another one. Evaluate the indefinite integral. Integral x squared over 1 plus x squared all squared dx. Well, what form is this? This is of the form a squared plus u squared. That's right. So we have 1 plus x squared inside the parenthesis, which is of the form a squared plus u squared, where a squared is 1 squared, so a equal to 1, and u squared is x squared, u equal to x. And so what is our substitution? Is u equal to a tan theta, u equal to a tan theta, u equal to x. So x equal to a tan theta, a is 1. So our substitution is x equal to tan theta. If x equal to tan theta, what is dx? We get dx equal to secant squared theta d theta. And what is x squared? X squared is tan squared theta. So in here, we will replace these two x squares by tan squared theta, replace the dx by secant squared theta, and that gives us the integral is now x squared becomes tan squared theta, 1 plus x squared become 1 plus tan squared theta, and that quantity is raised to the power of 2, and dx is secant squared theta d theta. What is the next step? What is 1 plus tan squared theta? 1 plus tan squared theta is secant squared theta. So replace that by secant squared theta. Now this is secant squared theta raised to the power of 2. And you can see this secant squared theta and a secant squared theta will cancel, leaving a secant squared theta. Remember, secant squared theta all squared is secant squared theta times secant squared theta. One of them will cancel and the other will remain. And you notice I just cancel the power. That means this is going to stay. So that will be integral tan squared theta divided by secant squared theta d theta. How would you simplify that? Well, this is not a form we can integrate easily, is it? So, whenever you have tan, cot, cosecant, and so on, try and change them to sine and cos. Tan squared theta is sine squared theta over cos squared theta. And secant squared theta is 1 over cos squared theta. There's a theta missing there. And what is this? Try it in your mind. It is sine squared theta over cos squared theta times, reverse and multiply. Cos squared theta divided by 1. And cos squared theta and cos squared theta will cancel, leaving us with integral sine squared theta. I hope you can deal with that. And how do you integrate sine squared theta? We had developed a method of doing that. You need to replace sine squared theta in terms of what? Cos of 2 theta. What is cos of 2 theta in terms of sine squared theta? Cos of 2 theta is 1 minus 2 sine squared theta. Therefore, what is sine squared theta? Sine squared theta is 1 minus cos 2 theta all over 2. We have done this several times. If you have difficulty, go back and review that again. Let me write down that identity one more time. It is cos of 2 theta is 1 minus 2 sine squared theta. Therefore, 2 sine squared theta equal to 1 minus cos of 2 theta, and divide both sides by 2. You get sine squared theta equal to 1 minus cos 2 theta all over 2. Alright, that's what is in here. And in order to evaluate this, we can split this into 2 if you want. Is that right? Or we can factor the 1/2 outside and write it as 1 minus cos 2 theta d theta. Alright? We can integrate this. What is integral of 1 d theta? Integral of 1 d theta is theta. Integral of 1 dx is x. Integral of 1 dv is v. Integral of 1 d theta is theta. Minus integral of cos 2 theta d theta is, well, I hope you remember, integral of cos theta d theta is sine theta. Integral of cos a theta d theta is sine of a theta divided by a. So integral of cos 2 theta d theta is sine of 2 theta divided by 2. So that will be 1/2 integral 1 d theta is theta minus integral cos 2 theta d theta is sine of 2 theta divided by 2. Well, are we finished? No. What do we need to do here? We have the original integral is in the form of in terms of x. We need to get these results back in terms of x. How? Go back to our original substitution. What is our original substitution? Well, I simplified this. Sine of 2 theta is 2 sine theta cos theta. But that will be much easier when you go back to our triangle. Our original substitution is x equal to tan theta. So what do? we use this substitution to construct a triangle. What is therefore tan theta equal to? Now, if x equal to tan theta, I hope you understand this skill. If x equal to tan theta, then theta equal to arctan of x. That's the inverse function that we talked about so many times. So if x equal to tan theta, then theta equal to arctan x. That means in this result, this theta can be replaced right away. What is theta? Theta equal to arctan x. And if x equal to tan theta equal to x over 1, opposite side is x, adjacent side is 1. Tan theta is opposite side divided by adjacent side. So we know the opposite side, we know the adjacent side, therefore what is the hypotenuse? That is theta. X is the opposite side, 1 is the adjacent side, therefore the hypotenuse will be, the square of the hypotenuse is 1 squared plus x squared. Therefore the hypotenuse will be square root of 1 plus x squared. There you go. So in this case, therefore, we need to now find the value of sine theta and cos theta. The value of theta we already know. What is the value of theta? Theta is arctan x. Alright, in this triangle, what is sine theta? Sine theta is opposite side divided by the hypotenuse. That would be x divided by square root 1 plus x squared. There you go. And cos theta is adjacent side divided by hypotenuse, which is 1 over square root 1 plus x squared. So, in the results that we obtained in terms of theta, we replace theta by arctan x, replace sine theta by x over square root 1 plus x squared, replace cos theta by 1 over square root 1 plus x squared, and that gives you this result. 1/2 of theta, 1/2 arctan x, minus sine theta cos theta. You can see square root 1 plus x squared. Here, this one. 2. This one is 2 sine theta. 2 sine theta is 2 times x over square root 1 plus x squared, times cos theta is 1 over square root 1 plus x squared. And that gives you, you can see the 2 and the 4 cancels, leaving a 2 at the bottom. And x times 1 is x. Square root 1 plus x squared times square root 1 plus x squared is 1 plus x squared, and that will go to the denominator. So our answer is 1/2 of arctan theta minus x divided by 1 plus x squared. Now here, if you notice, the 2 and the 4 goes, leaving a 2 there. That means there is a 1/2 in this term and a 1/2 in the first term. It is that 1/2 that has been factored out. So 1/2 and 1/2 has been factored out, leaving arctan theta minus x divided by these two multiplied gives you 1 plus x squared. And that is the final result. Alright, let's try another one. Evaluate the integral. Integral 0 to 2. We have a definite integral here. X square root 16 minus 4 x squared dx. What form is this? Of the 3 forms we started with, this is of the form a squared minus u squared, isn't it? See, the constant number will be always the a part. This is of the form a squared minus u squared, where a squared is 16, means a equal to 4. U squared is 4x squared, means u equal to 2x. That's right. So, this is of the form a squared minus u squared with a equal to 4 and u equal to 2x. What is the substitution we make here? which is of the form a squared minus u squared. The substitution will be u equal to a sine theta. U equal to a sine theta. Our u is 2x. So we said 2x equal to a sine theta. A is 4. I want you to watch this carefully. The normal substitution for this form is u equal to a sine theta. Our u is 2x. So it becomes 2x equal to a sine theta is 4 sine theta. Well, we find the differential of both sides. Alright? So, if 2x equal to 4 sine theta, then x equal to 2 sine theta, is that right? Divide by 2. And x squared is 4 sine squared theta d theta. So, our x will become 2 sine theta, and x squared becomes 4 sine squared theta. And what is dx? If x equal to 2 sine theta, dx will be 2 cos theta d theta. Now we are equipped to replace everything in here. We have x equal to 2 sine theta, there you go. We have dx equal to 2 cos theta d theta. We have x squared equal to 4 sine squared theta. All these came from our substitution, 2x equal to 4 sine theta. Let's replace in this integral all these quantities. What did you get? X is replaced by 2 sine theta. Square root 16 minus 4x squared became 4 times x squared is 4 sine squared theta. Became 16 sine squared theta. And dx became 2 cos theta d theta. Simplify this. Inside the square root we can factor out as 16. Well, before we do that, because this is a definite integral, we need to replace the limits using our substitution. What is our substitution? Our substitution is 2x equal to 4 sine theta, or x equal to 2 sine theta. Now, when x equal to 0, what is sine theta? When x equal to 0, sine theta also is 0. And if sine theta equal to 0, then theta will be equal to 0. Because sine of 0 is 0. That means when x equal to 0, theta will be equal to 0. That limit will remain to be 0. And when x equal to 2, alright, we have x equal to 2 sine theta. When you replace x by 2, you get 2 equal to 2 sine theta. Now, if 2 equal to 2 sine theta, it means sine theta equal to 1. If 2 sine theta equal to 2, it means sine theta equal to 1. And sine theta equal to 1 when theta is pi by 2. So our limit of integration becomes for theta from 0 to 2. You see, the advantage is once you change the limit from x values to theta values, we don't need at the end to go back to x. That exercise of using the triangle can be eliminated once you change the limits in terms of theta. That is the advantage for a definite integral. Alright, let's do that. This has now become integral 0 to 2 x square root 16 minus 4x squared dx now become integral 0 to pi by 2 sine theta square root 16 minus 16 sine squared theta times 2 cos theta d theta. And we simplify this so that we can integrate it. First of all, inside the square root, we factor out as 16. And then we have a 1 minus sine squared theta there. Is that right? 16 minus 16 sine squared theta is 16 times 1 minus sine squared theta. What is 1 minus sine squared theta equal to? 1 minus sine squared theta is cos squared theta. So we replace that quantity by cos squared theta, we have now under the square root 16 cos squared theta. 16 cos squared theta, you take the square root, become 4 cos theta. That's right. So that will be 4 sine theta cos theta times 4 cos theta d theta. And 4 times 4 is 16, we can take it out. Sine theta cos theta times cos theta becomes this. 16 comes out. Cos theta times cos theta is cos squared theta times sine theta d theta. Alright, tell me, is it a form we can integrate easily? How? By another substitution. What is that substitution? Look at the sine theta d theta. You can substitute cos theta equal to u. So substitute cos theta equal to u, then negative sine theta d theta equal to du, or the sine theta d theta becomes negative du. So, also, when you do the substitution, always follow the limits with it. When theta equal to 0, look at the substitution. When theta equal to 0, what is cos of 0? Cos of 0 is 1. So when theta equal to 0, u equal to 1. There you go. That means this limit will now be replaced by 1 for u. When theta equal to 0, u equal to 1 from our substitution. Cos of 0 is 1. And when theta equal to pi by 2, tell me, what is cos of pi by 2? Cos of pi by 2 is 0. That means when theta is pi by 2, u will be 0. Cos of pi by 2 is 0. There you go. When theta equal to pi by 2, u equal to 0. So, our limits now become, what will be our limit? Our limit will be u equal to 1 to 0. Cos theta is u squared times negative du. So that will be, the negative comes out. Negative 16 integral 1 to 0 of u squared du. And that will be negative 16 integral u squared du is u cubed over 3 from 1 to 0. The upper limit will give you 0. So that will be negative 16 times the upper limit is 0 minus the lower limit, replace u equal to 1. That will be 1/3. Negative 16 times negative 1/3 is 16 over 3 is the value of that definite integral. A very, very interesting integration problem. Another one. Evaluate the indefinite integral. Integral square root 1 minus x over square root of x dx. Well, we have the expression square root 1 minus x inside the square root. Now, can this be used in such substitutions as a squared minus u squared form? Yes, we can. If you use a squared minus u squared form, a squared will be 1, which will give you a equal to 1, and u squared will be x. That will make u equal to square root of x. And so, we make in this quantity square root of 1 minus x, we will say 1 is our a squared and x is our u squared. So that gives you u equal to square root of x. Well, so we substitute what? What is a substitution? This is of the form a squared minus u squared. Our substitution must be u equal to a sine theta. Our u is square root of x. So we substitute square root x equal to sine theta. Alright. What is the differential of square root x? 1 over 2 square root x dx equal to cos theta d theta. Now if you look at our original expression, once we replace 1 by a and x by what? If square root x equal to sine theta, then x will be sine squared theta. So you replace x by sine squared theta. What will dx divided by square root x become? Dx divided by square root x becomes 2 cos theta d theta. So 1 over square root x dx is 2 cos theta d theta. So once again, when this x becomes sine squared theta, because square root x is sine theta, x equal to sine squared theta. So this becomes sine squared theta, then 1 over square root x dx becomes 2 cos theta d theta. And let's do that now. In this integral now, it will be square root 1 minus x becomes square root 1 minus sine squared theta, and dx divided by square root of x. Dx divided by square root of x is 2 cos theta d theta. Oh well, and 1 minus sine squared theta is cos squared theta. So that becomes square root cos squared theta. So what is now this? That will be 2 times square root cos squared theta is cos theta. It will be 2 times cos theta times cos theta, which is 2 times cos squared theta. So we got 2 times integral cos squared theta. How do we integrate cos squared theta? Again, you got to go back to the cos 2 theta form. Cos 2 theta is 2 cos squared theta minus 1. And that will give you cos squared theta equal to 1 plus cos 2 theta over 2. You got to learn these forms. And now this 2 can come out and cancel with the 2 on the numerator. This therefore becomes integral 1 plus cos 2 theta d theta. You can integrate it. Integral 1 d theta is theta. Integral cos 2 theta d theta is sine 2 theta over 2. And as usual, we will write sine of 2 theta as 2 sine theta cos theta. And our substitution, if you remember, is square root x equal to sine theta. Alright, tell me, if square root x equal to sine theta, what is this theta equal to? If square root x equal to sine theta, then theta equal to arc sine of square root x. That's right. So use the substitution square root x equal to sine theta to express the answer in terms of x. Because square root x equal to sine theta, theta equal to arc sine of square root x. And also we write like this, sine theta equal to square root x divided by 1. Well, anything can be divided by 1. Why did we write like this? Because sine theta is opposite side divided by the hypotenuse. So, if you now draw a triangle with theta as the acute angle, we have sine theta is square root x over 1 means the opposite side is square root of x and the hypotenuse is 1. So we get the opposite side square root of x, the hypotenuse is 1, therefore what is the adjacent side? The adjacent side will be square root of 1 minus x. Why? Because the square of the adjacent side is 1 minus 1 squared minus x squared. Is that right? 1 squared minus square root x squared, or it is 1 minus x. Therefore the adjacent side is square root of 1 minus x. And so we need to find sine theta and cos theta. What is sine theta? Sine theta is opposite side divided by the hypotenuse. So sine theta equal to square root of x, which we already know. That's our substitution. And what is cos theta? Cos theta is adjacent side divided by the hypotenuse, and that is square root 1 minus x. And let's, in this result, replace theta by arc sine square root of x. Sine theta is square root of x. Cos theta is square root 1 minus x. So our results will be integral of square root 1 minus x over square root x is theta, that is arc sine square root of x, minus the 2 and the 2 there cancels. Sine theta is square root of x, cos theta is 1 square root 1 minus x, and we can factor out a square root of x. No, there's nothing you can factor out. So that will be arc sine square root x minus square root of, since square root of x times square root of 1 minus x, we can actually put that whole thing in one square root as square root of x times 1 minus x plus c, and that is the result. All right.